Okay, the next lecture is about the method of fermentation and bioreactor system. Although it is said here that it is for week 9, this one is actually for week 9 and 10 because there are 70 slides or more. So these slides are prepared by Dr. Hanasan. I'm just giving you the lecture. Okay, this one you can read it by yourself. Okay, the outcome of the lecture. For the introduction is just a recap from our last lecture. Fermentation is a metabolic process which converts carbohydrates to products by the activity of enzymes of microbial origin. I think the keyword here is microbial or microorganism. Of course, everything that is being converted from the substrate need to use the enzyme. And the microbes that we usually use in fermentation process is bacteria and fungi. So far, we still don't have any capacity to use virus. Okay, for microbiologists, the word fermentation means many processes. For example, mass cultivation of microbes under aerobic or anaerobic condition. Certain biochemists, they have a stricter definition of fermentation, whereby you must use anaerobic conditions only. If you use aerobic condition, it is not considered as fermentation. The fermentation also produce many kind of product, for example, alcoholic beverages, for example, beer, wine, and so on, organic acids, antibiotics, and biopolymers for industrial application. Fermentation can also be defined as partial oxidation of carbohydrates to produce other products, or partial oxidation of substrates. Previous lecture, we also take a look at the possibility of using fermentation on protein and lipid, which is also possible. Okay, for industrial fermentation, which is a large scale, they are usually divided into two main modes of fermentation. The first one is submerged fermentation. In another word, we use liquid. Another one is solid state fermentation, or we use solid as a substrate. For submerged fermentation, there are three types. The first one is batch, means no nutrients in and no waste out. The second one is fed batch, which means we put in the nutrients into the fermentation tank, but we don't take any waste out from the fermentation tank. And the third one is continuous, which means there will be nutrients into the fermentation tank, and we also take out the waste from the fermentation tank. For submerged fermentation, which is liquid, it is a control process for microbial optimal environment in a liquid broth in shake flask or bioreactor. Actually, as long as you have a tank, it doesn't have to be shake flask or bioreactor. Sterility of the material through aseptic technique, because we want to make sure inside the fermentation tank we only have the strain or the microorganism that we want. So there will be no contamination, so the product that we produce is the one that we want, the one that we desire. The fermentation condition is controlled by setting the temperature, okay, to get the optimal products, pH, dissolved oxygen, and mixing. Agitation. Mixing can be done using this stirrer, okay, attached to the motor. I think we already take a look at the fermentation tank during our last visit to the biotechnology faculty before MCO. Okay, for batch culture techniques, okay, I'm sorry, I should go to the previous slide. For batch, as you can see, it is a closed fermentation system, no nutrients in and no waste out. For fed batch, you put into the nutrient but no waste out, so eventually the amount of the liquid inside the fermentation tank will increase. For continuous fermentation, you put in the nutrient and you take out the waste and also some of the microorganism. So the amount of the liquid will always be the same. Okay, for batch culture technique, as I told you earlier, it is called, also known as closed system of cultivation. It is prepared and inoculated with inoculum, or known as culture organism, once with continuous aeration, stirring. The nutrients will be consumed and the product of the growth accumulates in the fermenter. Product of the growth may be of two types. Either biomass, we grow the microorganism to use its biomass as food or as a product, or we want to extract the metabolites. The nutrient environment in the fermenter is continuously changed. Limited means because we only put the nutrients once, the nutrients will always be consumed and reduced over time. This will enforce change in the metabolism of cell. Now the cell is stressed, they will start producing these metabolites that we want. It will lead to stationary growth due to the scarcity of the nutrients and accumulation of metabolites and toxic products. Okay, because they will have limited nutrients and also accumulation of toxic product, eventually this microorganism will start to die. Okay, so we will take a look at the bacterial growth curve later on. Okay, continue. Metabolites are extracted from the fermenter by downstream processes, purification of the product. So we take out the liquid from the fermentation tank. We can purify them using many techniques. For example, we can use chromatography, we can use filtration, we can use centrifugation, and so on. After the fermentation is over, the broth or products are taken out from the fermentation tank, and then the vessel is cleaned and sterilized for the next batch of fermentation. So that's why sometimes we call this fermentation as batch 1. The second one we call as batch 2, and so on. It will follow the growth curve phase of bacterial growth. Okay? I'm sure you learn about this bacterial growth curve during your undergraduate years. As you can see, we will have 4 distinct phases. The first phase is lag phase, where the bacteria is adapting to the condition. So the growth is static. And then the second one is log phase. After the bacteria adapt to the condition, they will start doubling and produce more of the bacterial cell. Okay? And eventually they will reach the stationary phase. Stationary phase is where the death and also the doubling of the bacteria is similar because they have limited nutrients. Eventually, because there will be limited nutrients and also more toxic waste, the cell will eventually die, okay, in the death phase. The one that we targeted in the batch fermentation is the stationary phase, because this phase is where the bacteria starts to produce the metabolites that you want. Okay, so you can read by yourself the advantages and disadvantages of this fermentation. Okay, for fed batch culture technique, it is a semi-closed system because you just put in the nutrients but nothing comes out. The first nutrient media is prepared and is inoculated with culture organism and then incubated for particular time. Okay, so we prepare the seed first and then we can put them into the fermentation tank. During the course of incubation, particular nutrient is added at intervals without removing the used up media. Volume of the culture increases continuously, like I said before. Because nothing comes out, the amount of the liquid inside the fermentation tank will continue to increase. Okay, periodical addition of substrate keeps the prolonged log and stationary phase. Okay, so if you take a look at this bacterial growth curve, the use of fed batch fermentation will help in maintaining the log phase and stationary phase. Okay, no death phase is occurring because we have enough nutrient. It will also cause rapid increase in biomass since nutrients is available. Consequently, increased production of metabolites can be achieved in stationary phase. Like I said to you before, the metabolite production usually happens in stationary phase. Okay, to be more precise, it is what we call as secondary metabolites. Primary metabolites is usually produced during log phase. In fermentation, some nutrients can be very essential for the process, but when the nutrients are provided in high concentration in the culture, they can inhibit the growth. Okay, for example, These bacteria, they require just 5 grams per liter of glucose. More than that, more nutrients, it can inhibit the production of metabolites. Okay, so what we do is we add 5 grams per liter of glucose over time, and when it decreases to 4 grams per liter, we increase again to 5 grams per liter. Okay. Therefore, such nutrients are kept in lower concentration initially and added slowly and continuously during the course of fermentation. Advantage is fed batch culture gives greater product yield than batch culture. But the disadvantages is chance of contamination of culture is higher in fed batch because we putting in the nutrients during the fermentation. So during that time, we can introduce contamination. Okay, the last one, which is a continuous culture technique, is an open system of cultivation. Fresh sterile medium is added continuously in the vessel, and used up media with bacterial culture is removed continuously at the same rate. So we add the nutrients, and at the same time we remove the waste and also some of the bacteria. So the volume and the microbial density remains the same. So if we just remove the nutrient and the waste, but we left the bacteria inside the fermentation tank, the microbial density might increase. So we remove them as well. So the microorganism will grow continuously in their log phase. Because they are usually in the log phase, means they keep doubling, keep growing. There is no stationary phase. Usually this type of fermentation is used to produce primary metabolites. Okay. So the metabolite of the product of the fermentation is extracted at regular interval. Okay, so we can take the product continuously over time. Types of approach of continuous culture, there are two types. The first one is chemostat and the second one is turbidostat. We will take a look at these two types of continuous fermentation. The first one is chemostat. As you can see here, the medium is fed at constant rate. Okay, fresh medium is continuously introduced at constant rate. The culture medium is keep constant by continuous removal of culture. Okay, continuous removal of culture at the same rate. The supply of a single nutrient controls the growth rate, limiting nutrient. Okay, or means that all nutrient is in excess. Okay, because the bacteria will need, for example, elements, calcium, and so on. They are all in excess. But one limiting nutrient, usually the carbon source or carbohydrate. For example, glucose is kept as limited. So as the concentration of a limiting nutrient reduces, we add more. Okay. So if the concentration of the nutrient is altered, then okay, so we have a sensor somewhere here. So it will indicate, it will detect that the nutrient concentration is altered. So we assume that it indicates the bacterial density is changing. So the flow rate is adjusted to maintain or change the constant cell density. In contrast to the second one, which is turbidostat, the nutrient is added as the turbidity of the bacteria change. Okay. In turbidostat, a photoelectric device is used to monitor the cell density in the cultivation vessel. The optimal sensing device measures the turbidity or absorbance of the culture in the vessel. If the concentration is altered, it is detected by photoelectric device, and the flow rate is adjusted to maintain the constant cell density in the culture. In this case, we don't have any limiting nutrients. Okay, we just based on the concentration or turbidity of the bacteria inside the fermentation tank. Okay. Okay, you can read the batch fermentation, the differences between batch fermentation and continuous fermentation by yourself. Okay, so thank you. We will meet again in the next lecture about the solid state fermentation, which is fundamentally different from the submerged fermentation because they use a solid state substrate. Okay? For example, tempeh production, koji, natto, and so on. Okay, thank you.